to the next session. We will have now the first case study of today. And this case study will be around the topic of protecting the important machines with advanced sound analysis. How can technologies like AI and IoT transform the way maintenance of machines is realized? And with me today is one of the event sponsors, Pavel Konechny from Neuron Soundware. Graduated in cybernetics and biomedical engineering, he began his career in IT consulting with Accenture. And because he was considered one of the most innovative team members designing the innovation every day, he was very often asked why he doesn't start his own business. And the answer was always the same: we need to wait for computers to be powerful enough to use AI. So that time has come about 4 years ago, where Neuron was then founded, a Czech startup that listened to machines and uses AI to predict failures and malfunctions on machines. So they use digital ear and brain to predict failures. And Pavel is the founder and CEO of Neuron. Pavel, can you please try to share your screen? Oh, you did already? Okay, I will then the presentation. And Pavel, the stage is yours.
Thank you. Good morning, everybody. So we protect machines and businesses. Yeah, and it's all in combination of the AI, which we extended, but also industrial IoT device. So we can use one of the best signals for machine mechanical recognition, providing some insight in how machine operates. Yeah, I'm happy to provide you guys through what we do and answer any questions you might have. So with our technology, we are tackling 3 key challenges, well known. So it's unplanned downtime, which costs a lot of productivity. The second is if a machine breaks, it might also make some collateral damage. So a small components you could replace on time. In the end, if that's not done, then you can lose a much higher value of the machine if it breaks much more. And the last one, it's all digitalization of all assets, or some of them, they don't have digital interface, or you need to run a big IT integration projects. And we decide also use our technology to help with that. So by just adding a microphone, we can tell when the machine operates, how, and to visualize it to our customers. So in essence, we are transforming a human capability of recognition of different patterns, audio patterns, into software. The whole concept and idea started with a friend of mine who was sharing his story as he was driving a car, and he could hear there is some strange noise coming from the engine. So he even stopped at the service. They didn't find actually anything on the onboard computer, so he just continued driving. And about 100 kilometers later, the cylinder broke apart. It blew up the whole engine. It was like 10,000 euros damage. And he shared it was very lucky. It was 2 days before warranty period ends. Yeah, so that human capability to learn how our car sounds and now it really well on different conditions. It's something we built in the algorithms so we can track and inform users if there is some anomaly happening in the machine. Yeah. And it can use variety of sensors. Of course, it could be on human hearing, and it's listening all the time. So with that, we built an all-in-one solution of predictive maintenance. So we started with AI and models, and then we decided to build affordable, high computing powered edge device, which is all industrial standards. Because we didn't find anything for the right cost on the market. So we have our N-Box, and it can have up to 12 channels. We streamline the data and process also locally within the edge. I will talk about a couple of use cases later. And we are collecting millions of recordings in our database. It has terabytes of data, which is used for training of the models. Yeah. And we are combining this with the maintenance logs. So we provide some insights how the machine operates, what was happened in the past, and improving the algorithm as we go. As a result, our customers get alerts, emails, dashboards. They don't need to worry about anything. Just connect the device to electricity sensors, and they got the full platform on their disposal. So a couple of use cases. One of the recent, it's escalators. So there are many mechanical components. We use about 12 sensors for each, and we provide information how it's being used, and again the anomalies. And not only it can save and provide some warnings of these critical assets within the public system in Prague, which is very deep. So if something broken, people cannot just make a new steps, like 50, 60 meters difference. So they are very important. But also it allows the customer to really reduce investments, because we are prolonging the lifetime of these assets beyond the planet, and that saves really tons of money. The other use case is a pump cavitation. So that's an event which happens in the pump, and we, with our device, can detect it in real time. So we, with 3 months running the service, we got 13 alerts that we detect cavitation. 10 of them was the problem. So we catch all of them with a few extra events. That's how we set it up, because the damage can be very severe. So customers would rather detect it on time than miss some. And again, it's the data processed within the edge. It's happening real time. We can also deploy it and response act through CR ports and send the message to the controlling system, something happening. So have a look or stop the machine. Moving to the front end, which if I have a bit time or there might be questions, happy to also look and provide a quick review. But feel free to visit the website and play a video, or just ask our colleagues through the forum. They will be happy to provide you a very deep overview of the platform. But it has a very quick onboarding wizard, which you can in 30 seconds activate and configure your machine. It has nice overview of dashboards of different machines and installation manuals, and every component you can be seeing if there's some alerts or no. Of course, you have access to data we are collecting, so you can compare the history and reply and add the events like a service log for the machine. So that's something we are proudly released last year and call it Shield. Moving to the topic how our business works. So we provide it as a SaaS model. So there's an initial activation fee, which includes the lease of the hardware and sensors for the period of the service. And we take about 2 to 10 days data to calibrate the models. So that's the nominal operation of the machine. And then we train it in our cloud service, and then you get the full service. So you can see how the machine operates within minutes after initial setup, but AI takes these couple of days to set up, and then you get alerts and all sensory data. So with our technology, we can kind of set it up for a really huge number of machines. So it's a really enormous market. Yahoo mentioned that it's about 120 billion euros in the latest report of precise equipment maintenance. Happy that they choose us as one of the examples of company which are providing the service. And it's so we kind of validate the algorithms on different transportation systems and cranes and diesel engines and electric engines and so on. So we got a quite variety of different assets. We also are able to do custom algorithms. In some case, we have a couple done in the past in the area of quality control or monitoring of some main processes in factories. So what's the big revolution with AI and IoT? It's extending the economical benefits of conditional-based maintenance. Yeah, so with more data, you also need to have people to analyze it, and it needs to be affordable. All these sensors, all these systems are very expensive, so it will not be like a valuable or have any return of investment. unless you automate all the stuff and you have a good quality, but shrinking electronics, processing data, and that's what we are leveraging. Yeah, so extend the number of assets which are economical to be maintained on conditional, or which are in the risk of having some big influence impact on the company. There are several benefits which are promised by this predictive maintenance 4.0, and this is what we are kind of focusing on. So it's not just availability, even that's something which I would say most of the customers are looking for, but you can also have some increased safety, optimization. I see it very important, especially nowadays with COVID impacting all the investment budgets. So there might not be a funds for replacing some critical machinery. So it's reasonable to deploy extra measures to protect the key assets, because if they broke, it might just bankrupt the whole company. Yeah, so that's something we see now as recent reasons why some customers are approaching us. So that's one of the key aspects of the COVID. The other ones is that with people in the factories, you don't know who might be in quarantine or sick in weeks. We believe that trends will be focused on factory automation, so make it people-less, and with our device, which from the operating cost is equal to a person walking in the factory and collecting about 1,000 different data components points for the equal cost, is that you can keep your people safe. We call it like a home office for maintenance teams, so they can be in kind of remotely monitoring their assets and reducing their risk of health exposure and make it more risk reduced. Some of the brands we work, so we got many projects operated in the past in kind of phase of pilot concepts. Now we standardize our service and build an initial platform out of all experience. So that's we got about 25 different installations and assets of different customers, and that number is growing every month. And as I mentioned, so some of the key essentials are also in this predictive maintenance, but with a couple of other monitorings when we respond in real time on events when a robotic line get blocked, and we light a siren, call the service to come and fix that problem before the robotic line kind of stops and influence the whole process. So why audio? And what we see is what's the difference between predictive maintenance 4.0. So it's not just visual or instrument inspections, which is pretty common nowadays, but we go even beyond the real-time conditioning. So it's using the high volume data, the AI is automatically trained, and our device with our sensors, we kind of are collecting broad frequency spectrum. So it starts with new hertz like vibrations. It go beyond human hearing, so ultrasonics, and that complex algorithms allow us to pick much sooner any symptoms of potential mechanical failure coming. Yeah. So audio, it's one of the best signals. It's combined these sounds and vibrations. That's what we are processing. We also have some first trials using thermal cameras, which is also one of the powerful signals. These are the green columns on the table, which also selected by Airbus when we get discussions about maintenance priorities across their components they operate. So they kind of find correlation between the break evens across these four sensors. The last one maybe with the least importance factor, but for some machines, it's also a useful source of information. It's intensity of current. So we also have one pilot project collecting that. But the really mechanical sense, it's the most important. Okay. So really quickly, because all the specs are available on our website, so you can just browse. But we have Nbox, which is the edge device with LTE capabilities, so you don't need to have any IoT, any IT projects, any kind of firewall settings. You just plug SIM cards. So we have also prepaid European-wide plans, so we can provide also connectivity as a part of our service. We have a device we call N-card, which is audio card. We design it to work with our standard structure bond sound sensor, and you can also connect it to a mobile applications which will upload the data. And the sensor itself, it's a quite durable piezo element, which provides really good correlation between the mechanical signals and the measurements. And we just recently completed the ATEX certification, so we can deploy it also in high-risk explosive environments in petrochemical plants. So as we get a bit of time, I was just thinking also to go a bit more technical, so we get more time on going through of how we do the data pre-processing and use the AI to separate the useful signal from. So let me go within that. So first, we don't work with just a spectrum, but we are processing spectrograms, which combines time and frequency changes, so we have better insight what's happening in the machine. And that's the start point. It's further processed. So one of the key elements is to separate when actually it's the useful time. To analyze when is the right operating time. So we, as an example, that's a compressor we are monitoring. So we first identify when the compressor is running and ignoring the other sounds which might occur, like some condensations and compressors and pumps. Then we do some proprietary sharpening, and the output is these two-dimensional diagrams, which we call sound maps. So they represent the original sound, and that was actually AI's kind of looking. So it's on these diagrams. So it's very similar to the visual processing. And the next step is to build a model using this as input. And to do that, we have really extensive database of these millions of recordings, different types. And so that's the first step. Then we have machine-specific sounds. So we collect enough samples, we combine it from different machines of similar type into one larger data set, and we train it bits to understand better the audio space of that machines. And then we train it on different components of these machines, and we have the nominal sounds of millions of recordings, and the real trouble is to get the samples of brokerage. So we develop methods how we combine the real ones we collected with augmented type of errors. So we kind of build 100,000 different samples, which represents all type of failure modes so the machine might have. And that's kind of encoded in AI, and that's in the end, it helps really a lot. The green line, you can imagine, it's a single machine. On the diagrams, a similar machine, maybe a bit different operating modes, might be a bit different green error, but that's how we can see it. Yeah. So and we calibrate for every single machine the AI model in the second step. Every single AI kind of it's monitoring each sensor. Yeah. So we take stream data from every single machines. We collect it for these 10 to 2 days, and we fine-tune the model so it can track really precisely how the machine operates and detect these failure modes with high accuracy. Yeah. So moving to an example, that's something which is like a broken engine cylinder which got stuck on a big diesel CHP unit, and about 2 days before anything was noticed by any other methods, and the engine actually stopped working. We could go track it, and it increased the alert from the nominal score, and if it gets the thresholds, then we send warnings and alerts to use, hey, there's something happening, check it out, and tell us if that was a good catch. Of course, algorithms is improving, so we measure it in real data and some other alternatives. So these are eventually all mechanical failures. So they typically manifest days in advance, and we update the models, and it's about like 60-90% accuracy before anything else happens, and that's about the score. What we want to achieve is to prevent 9 of 10 failures, even if they're happening, and there's no other method how you can detect it today. So moving on to summarize the key benefits of our solution is that it's real time. So that's one of the things, as we are able to process data locally within the edge and do it like every second, every minute, not just once an hour, for example, but every second we can kind of deploy it and broad number of use cases and work on assets which don't have a regular maintenance or operating schedule. Yeah. The second is that you can very quickly deploy it to many different assets. Yeah, nevertheless, who the vendor is, and we can provide you an overview of how the asset is used, so you can work on the OEE. The AI, it's trained and it's continuously learning through our service. So every quarter or as needed, we are improving. We take all the data, we take all the ideas, we have more experience, and we update the models. It's all happening on the background. Just get informed that it was deployed by our service managers. And with the AI edge computing, we are also able to kind of local deployment. Some customers want to keep their data as close within the kind of security or factory arrangement, so we can achieve that as well. So finally, all these online tools are kind of available on any device. So it's fully responsive and very simply configurable. Also, our partners are now configuring the service for our customers. And of course, if you would like to integrate, get results, send us data, we have well-defined APIs. So with that, thanks for attention, and I'm happy to answer your questions from the chat or if you want to speak out.
Thank you very much, Pavel. I think it was a very interesting session. We had that topic of condition monitoring yesterday a few times, and I think for the audience it might be, or it is, as I assume, a really hot topic. We have some questions, and I will pick them here very quick from the Q&A. There is one question asked by Marco. The sound analysis is extensively used in some industries, such as hydropower plants, to monitor the conditions of turbines. We have piloted at Stora Enso sound analysis in our paper and board production lines, but due to very noisy environment, we have not managed to get it working reliably. What references do you have, for example, in mining or paper and pulp today, where we have high surround noise?
Yeah, that doesn't matter. Yeah, so we are monitoring CHP units, which are like 120 decibels. They are even closed in container. It's really big design. You need to have like headphones to be inside. Yeah, and that's the structure bound sensors are mounted to different components. Yeah, so it's not a single sensor which listening from air sounds. We really take these elements and we mount them to the machine. So you can differentiate different machines even if they are one next to other, and different components of one complex machine. Yeah, there are some sounds which come through the metal connectivity of the machine. So like one big metallic block, then you will hear the sound coming through. But but that's okay because the AI will adapt to it, and if there's some a bit background noise, it will just learn to ignore it. Yeah, so definitely suitable. We even had to like a bit change our preamplifier to work with larger noise levels than we anticipated in the beginning. Yeah, that's not an issue at all for us.
Okay, perfect. One more question. How do you integrate? You talked about API. How do you integrate with existing predictive maintenance solutions that use data from many sources? For example, automation systems, ERP, probably multiple condition monitoring systems. So maybe you can share some experiences about...
Yeah, we prototype integration with SAP, so we can tackle the APIs and them a message about the state of the health of the machine. What we learn is that we are collecting much more time data than they are able to process. So we only send the events and alerts in the end, because letting them know, okay, still okay. They don't have the typical data bandwidth and use for it. Yeah. So some customers are happy using our the front end or just with email, SMS. We ask the interface to 20 assets in the big factory. So they want to see it in action, and I believe that the big integration topic will be something which will be coming in the coming years.
Okay, perfect. One more question, because you're concentrating on sounds, right? So are you only providing sound solutions or also temperature, vibration, or do you just don't need it anymore, the vibration?
Yeah.
So
So we work with temperatures, we work with magnetic fields, or any streamlined data, which is the same character as how they are processed the same. We also proceed some a very specific high fidelity 2 gigahertz data sets. So the AI doesn't care, the same principle it's applied. The audio, it's the best indicator. Yeah, so temperature is nice, a bit add-on, but definitely the audio provides the best results. And maybe I can quickly go through a couple more questions. So there's about how the training is organized. So a customer, they just in the tool tell us, okay, this is the nominal sound period. So I plug it in, it's all set it up. I have now machine well maintained. They highlight it in the tool, and then we click it, and it's being trained. Yeah. So that's something which they will get notified when the model is finished, and that they can they will see it in the online dashboards. Yeah, all these graphs and so on. So that's so they will get the information. Now, there's one quick question about IT security. So we are typically independent to the network of the customer. We care about the device. It's being updated. It's like a small Linux server. So we have all these point-to-point encryption keys in place, and so that's kind of well managed and secured, following the best industry standards.
Perfect. Thank you. No more additional question at the moment. I think we can meet you or your team in the lobby or in the lounge even. You can grab a seat there in the coffee break we will have after the next session. So you will be available for us. Pavel, thank you very much for this interesting presentation. You get quite a few thumbs up. So very good presentation. Thank you very much. And
thank you. Happy to talk to you guys. Just connect us.
Perfect. Thanks. Bye.
Bye.